Advanced Math Lesson 30. Part A is about adding vectors. Okay, so I have your blanks filled in. You can copy this as I sort of talk about it. There are a couple other things we'll add right here. A vector has a magnitude and a direction. Magnitude is the R, the number we put in front of the angle symbol, and a direction, and that would be your angle, if it's in polar form. It can be designated using polar coordinates, which is what I was just talking about, or with rectangular coordinates. That's the I and J, or the coordinates of a point. Okay, that part you already knew. Vectors in polar form can be added only if the angles are equal, or if they differ by 180 degrees. So they're either going in the same direction or opposite directions. Then you can add or subtract. And what that means is, if you had, let's say 2 for your R, and our theta is 30 degrees, and we're adding another one to that, let's just say 3 at 30 degrees, you could add the numbers in front, the magnitude, and you would get 5 at 30 degrees. And the reason is, okay, so 30 degrees is in here someplace, there's a 2, and then that was the first one here. For the second vector, it's the same rotation, but it's 3 more units out. So 2 there, 3 here, is a total of 5. You just have one that keeps going in the same direction as the other, you add their magnitudes. If instead this were down in the third quadrant, so it'd be like 210 degrees, then they'd be going in opposite directions, so we would have subtracted instead. But that only works when those angles are the same, and that's going to be very rare. So we can only do that when that happens. That means we have to have another way of adding vectors. That is changing them to rectangular. So otherwise, if they don't have the same, or the same angles or differ by 180, then the vectors have to be written in rectangular form. And then to find your resultant vector, so just what you get when you add them, you add the i's, the horizontal parts, and you add the j's, the vertical parts. So it's basically turn them both into rectangular and then add like terms. And we'll be doing some of that. Vectors are often used in physics applications. They're used in other things too. But in that context, it can be to calculate the end result of multiple forces acting on an object. The resultant is the sum of those forces. And that's what these diagrams are trying to show you down here, and I thought I'd try to color code a little bit. So we have vector 1, is right here. Okay, that arrow. Over here, vector 1. Okay. And then in the middle one here, vector 2. Down over here, that's on the right. Okay. So there's an object here, and it's getting pushed that way by one force, okay, this way along that blue line, but it's also getting pushed this way along that pink line by some other force. The end result is somewhere in between. Okay, and how we find that is adding those vectors. And so I just picked purple because blue and pink. Okay, so that is what we get when we combine them. So that's where your object would end up. It's getting pushed kind of up and right by one force, but down and right by another force. And so we add them, and that's your resultant. That's what you're doing when you're adding these coordinates. Okay, so the resultant is the sum of the forces. We talked about that. There's also something called the equilibrant. That's here. The equilibrant has the same magnitude, same R, same number in front of the angle symbol, as the resultant, but the direction differs by 180 degrees. Okay, so the equilibrant is the force to push back to stop this thing from moving. Okay, there's two different forces acting on this object, trying to move it. You find the resultant that shows where it would end up. The equilibrant is pushing back in the opposite direction of that because it's pushing back to make it stay in place, to keep it in equilibrium. Okay, so it's going to be the same magnitude as this resultant, but opposite direction. So you either change the sign of the magnitude, or you would add or subtract 180 degrees on your angle. So I'll show you that. So here we go. Example 1. Find the resultant of, and I couldn't find a good way to format that. There. Find the resultant of these two vectors. All right. 20 and negative 230 are not the same, and they do not differ by 180 degrees. So we have to change both of these to rectangular coordinates first. Then we'll add. And then we should typically give our answer in the same form the problem was presented. So we're going to, at the end, change back to polar since it started out polar. Okay, so it's a bunch of things you've already done, just all in one problem. All right, 20 degrees. That's in this quadrant. That's a 4. Okay, we need to find our x and y. And we have the hypotenuse. And let's say we're looking for x first, the adjacent. I'm going to take so much room there with that. So that would be cosine. Cosine of 20 is adjacent over hypotenuse for cosine 20, and that means we'll have the same setup for sine to find y, or with sine to find y, and we'll end up with 4 times the sine of 20 equals y. So I take my calculator, and 4 cosine 20 I'm going to do 4 decimal places. So x is 3.7588 when I round. And then for y, I have 4 sine 20. And I'm getting 1.3681 when I round. All right, then we need to, well, I can go ahead and write that in my rectangular form now. They're both positive because it's in the first quadrant. So we have 3.7588i plus 1.3681j. That was our first one. Now we do the same sort of thing for the second one. Negative 230 is going to be in the second quadrant. I'll go over here. Get that long again. Okay, so we're here. If there's 180, another 50. Well, make our 230, so this is 50. We need to find our x and y. The hypotenuse is 7. Okay, so that means for x, we would have cosine of 50 is x over 7. Multiply both sides by 7. And then again, 7 times the sine, 50, will give us y. Calculator, 7 cosine 50, 4.4995. And then 7 sine 50, 5.3623. Okay, now we're in the second quadrant. The x is negative 4.4995i. The y is positive 3623j. then we add. Okay, so 3.7588 minus 4.4995. I'm getting negative 0.7407 I, and then the other ones are both positive, so I add them. 1.3681, 5.3623, 6.7304, J. So there's the resultant in rectangular form, but we need to put it back into polar form. Now, the good news is you don't have to put it in all four of them. You can just put it, like, write the answer once. All right, so now we I'll do a little sketch, I guess over here. Okay, x is negative, y is positive. We're here. The length of this side is 0.7407, and this one is my 6.7304. I can find the hypotenuse using the Pythagorean theorem. That'll be our magnitude. So, we'll be doing the square root of 6.7304 squared plus 0.7407 squared Okay, and I only did the 4 decimal places for my work so that I wouldn't keep getting a little further away from the exact answer due to a bunch of rounding. Now we're going to just put our magnitude in 2 decimal places, so 6.77. And then we'll find our angle. All right, so we can do inverse tangent here. We're looking for that angle right now. Often we use theta prime for the related angle. I'll do that. So the tangent of that angle in here would be opposite over adjacent. So we're doing the, 7304.7407. So we're doing the inverse tangent of this fraction. So second tangent, 6.7304 divided by 0.7407 equals I think I've had a typo. Okay, I checked. No typo. I did more decimal places in the book. We didn't quite match, but okay. So that angle, our reference angle, is 83.72. I got 83.73. We're closer. But yeah, so theta prime is, we're going to say 83.72 degrees. But that's not the angle that goes here. The angle that goes here is going to be that one. So now we need 180 minus this angle that we got. So looks like 96.28 right here. And that's it. We'll do more. Okay, so over here we have example 2. 2 forces, here they are being applied to an object. Find the equilibrant. So make sure you're reading these carefully. This is one where we have to find like what's pushing back to make it not go anywhere. So first we find the resultant, and then we do the opposite of that. All right, so 50 degrees in here, hypotenuse is 4 again. And then this one, okay, 170 degrees positive is going to be over here. Okay, but we have a negative r, which means we're actually going down here. If that's 170, this is 10. That means this is 10. This is 6. Okay, and then for cosine 50 will give us our x. For sine 50 will give us our y, because we did the same thing we did in example 1 for that. And then here we have 6 cosine 10 and 6 sine 10 for that x and y. Okay, let's find out what all those are. For cosine 50, for sine 50, okay, then 6 cosine 10, and 6 sine 10, okay, now let's write these in rectangular form. They're both positive for the first one here. 2.5712, 3.0642, for that one. Oh my. Not ready for that yet. Okay, 642. This is the j for the first vector. All right, now to the second vector. This is, we have a positive x and a negative y. So 5.9088i, that one's positive. The y is negative, so minus 1.0419j. All right, so let's add them. I still have this number in my calculator. I'm going to do the j first this time. 3.0642. So I'm getting 2.0223j. And for this other one, I have 2.5712 plus 5.9088. 8.48. Okay, so that is the resultant in rectangular form. And now we're going to change that to polar form. They're both positive, so first quadrant. And we'll do the Pythagorean theorem to get the r. So, for my calculator, I'm doing the square root of, and then I have 8.48 squared plus 2.0223 squared, and I'm getting 8.72 if I'm not doing 2 decimal places. Okay, now that will be the r, and now we need to find our angle. So we'll do inverse tangent again. So inverse tangent of opposite over adjacent, 2.0223 over 8.48. Do it on the calculator. 2.0. Whoops, I missed my 0.223 divided by 8.48. And I'm getting 13.41 degrees. Okay, this would be the resultant. That's what we got when we added them. We're supposed to find the equilibrant this time. Just always make sure you read the directions. Sometimes they want one or the other, sometimes they want both. So, now's where you have an option, and in order to write this, you can keep that angle and just change the sign. That'll make it go in the opposite direction, because you know when the r is negative, that flips it. That moves it 180 degrees. So a way of writing this answer is simply to change the sign of your r. Your other option for that would have just been to add 180 degrees to this. Okay, so you don't have to do both, but I want to show you that here we could have kept that r and add 180 to this, so 193.40. Either one of them would be fine. They're the same thing. Okay, now one more example of this, and then I think our video will have been long enough. I might split this into two. So, what vector force must be added to a force of... Okay, so now we're going to be subtracting, because we're doing... Okay, what vector, we don't know, I'm going to put V for vector, is being added to this, right, to get this resultant. Okay, so I made an equation out of this. I need to find out this vector. That means I'm subtracting this from both sides. So the vector is going to be that. Subtract it from this side, subtract it from that side. All right, so that's what we're actually going to do. This one's pretty nice, I think. Okay, so 0 degrees is right here on the x-axis, 25, right? The length of that's 25. So our I is the x, that's 25. Our j is the y, that's 0. That's it. First one, 25 for the I, 0, which I guess I wouldn't even have to write, for the j. X is 25, y is 0. Moving on. This one. Okay, 30 degrees, that's up here. And for this one, okay, 30 is also nice of them. Your hypotenuse is 20, and it is a negative there. I could flip it and add, but I can also just subtract what I get from this other one. Okay, so let's just do that. I need to find my I and j, and this is a special triangle. So you could use what you know about the proportion, like the ratios for these sides, or you could just use your calculator, however you choose to do it. But you know, this short side is half of that side, so this is going to have to be 10. And then over here is your 10 root 3. But everything else is decimals, so what's 10 root 3? It's a decimal. 10 root 3, that would be approximately 17.3205, since I've been doing 4 decimal places. All right, so for the second one. That is our x. They're both positive. So I'm putting 17.3205i. And they're positive here, but don't forget we're subtracting them. So I'm going to make that negative because I'm subtracting from the other one. And then minus my y, which is 10. J. Okay, so what is 25 minus 17.3205? It is approximately, well, 7.6795. And then here we have minus 10j. Okay, and we are putting this back into polar form, and that'll be that. So, do the sketch over here for this one. X is positive, y is negative. We're down here. The y is 10. The x is 7.6795. We need to find the angle and the magnitude, so let's do the magnitude. Square root of 10 squared plus 7.6795 squared looks like 12.61. And then we need that angle, so second tangent 10 divided by 7.6795. So this, I'll call it theta prime again. Theta prime is 52.48, rounding a little bit. All right, so actually, we can just say negative 52.48. I forgot to put my labels on the one up above. That one was pounds. This one is newtons. Don't do what I did. Don't forget those. I'm just going to write the pounds in the middle up there on the top. I didn't have a lot of room to add the pounds there. This was newtons. We could have given a positive angle instead, just do 360 minus that. It doesn't matter which of the forms. Just, I don't see any reason to make both of them negative. Have at least one of them positive. But that is it for them, and I'm just going to stop here for now. We'll do part B in a separate video.